Okay, welcome back. I'm sure you all enjoyed that long break. Now I'm going to move into showing you the next example. So far we have covered or you have learned how to create a project, how to set debug options, and how you can enable your console window that's SWV to see your output. Now I'm going to include more code in so you'll get more in-depth debug experience in here. So to do that, I'm going to just copy this project and going to use it in the second project. So just paste it, and it's asking for a different name because it's going to be a different project. So example 2, you're still on day 5, and then click copy. This will generate and it will copy all the contents from example 1 and it's moved to example 2. So go to source code, source folder. Sorry, I pressed it too long. So going to main, going to syscall. So that's from example 1. So I'm going to close example 1 altogether, not to confuse you. I'll close that window, and also you don't need this window, so I'll close this as well. Okay, so I already copied the debug files in project 1, so you don't have to redo it again, and also did the changes in int right for sending characters, so that's done, which is good. So now I'm going to go into main program. I'm going to include more lines of coding, which you will see in a while, and this will give you more in-depth debugging options. So I'm on int. I'm going to create two different functions. Int a, int b, and the next function is int sub int a, int b. So I declared the function. Now I need to call the function, and I need to say what the function is supposed to do. Int a, int b, open the bracket and close. What is I need to store the result, so I'm declaring the storage location and what add supposed to do. Add should do a plus d and return sum. Yeah, return sum. Just give me a second. Just checking. Okay. A plus b. So likewise, I'm going to do for the diff int sub of int a comma int b, then int diff, and what the diff supposed to do. Diff is a minus b and store the result in diff. Okay, so we done that bit. Now I'm going to do some changes here. Add two numbers, and what that's supposed to do. So sum equals add of a comma b in here, and this will add the value, and then I have to print the stored value. I have to show in the result. So doing that, printf sum of two numbers being integers. I need to use that percentage of d backslash of n and which result you want to see. So that's for print. So sorry, copied it the wrong place. Space. Okay, that's sum. So now you got to do the same for the diff, which I will include in here. Sub two numbers. And what's the diff has to do? Diff equals sub add a comma b, then printf diff of two numbers is, and which variable is diff. I need to include the local variables in here and initialize it. So I'm going to do a minus b, so I'm going to give a equals 10, b equals 7, then sum comma diff. So I declared all of that diff. Okay, std out diff sub comma b sum add a comma b equal 10 sum and diff return. Okay, so that's pretty much I have to show. So I'll save this project and compile it. Save, right click, build the project. Building up to 19%, just bit more patience, just doing all the internal checks and creating all the listed files. So that's happy with the included files. And now you got to set the debug option. So right click, this time choose debug as, go to debug configurations, and this time you're going to configure example 2. By default it comes as example 1, but change that to example 2 and example 2 there, and you got to browse and you need to link example 2 ELF file into the application where you are targeting. So clicking on browse will take you to the folder where you created in the desktop ESD ARM Cortex M4 demo. Inside the target, inside example 2 d5 on debug, if you see it's on example 2 d5.elf. So open that and link that to here, and on the debugger make sure the ST-link is enabled and the serial wire viewer is enabled. So once that's done, then click apply, and then click debug. apply debug, so it will start the IDE to do the conversion from C, C++ to S, and it will change to debug options. Example 2 debug. Zero errors, which is good. We'll go into SWV ITM. It still haven't done the switching, so just wait a bit. Patience, 89%. Waiting for debugger connection, and now it will ask for us to switch. %. Yeah, it's happy, and it created the main function in the debug. Okay, so now let's see the output. So we already created this and enable port 0, if not enable port 0. All you have to do is go here and click the program step by step. So first click, it executes, checks for printf statement, and second click, it executes and checks for the second flush statement. Now it comes to the add two numbers, and it will add the two numbers, go to the sum, and now it's going to display what will be the result of two numbers is. It's going to print sum of two numbers, so which is 10 plus 7, because we're given so much printf statement, so it has to check all of that, but the result is sum of two numbers is 10 plus 7, which is 17. That's what we want. So I'm going to go and hit resume run, the full run, so it will give you the value. It will keep the value of 17 and 3, 17 and 3, 17 and 3. So there you have it, the second program that you can see the input value and the output. It's there. So I'm going to just stop that, and I'm going to give you more in depth about this code that we just written. So I'm going to stop this by just clicking stop. It will stop the debug option. That completely comes out of debug. So when you do that, it will come out of it. Then you have to go back to debug again. Instead of that, you could actually do terminate and relaunch, so you don't have to do this again. I'll show you in the next window. Choose die 2, yes, and click debug. Yes. Okay, it's not detected because we stopped, and it will ask to debug. Debug configuration. Make sure it shows that example 2 d5 and debug. and wait for the launching example to finish 100% so you can get the second program there, and I'll show you to assess and see the values of variables and how to see the expressions and to set breakpoints. Sorry. Yeah. Now click switch. So it's switched, and you know when you click run, you are able to see that output. When you do step by step, it prints, it executes step by step, and then it gives you that printf statements. By clicking on step by step, it goes every time, goes inside the function, checks for it, goes out of function and checks for it and finishes. So that's how it operates. So as you can see, there is plenty of other windows it's open. So click on variables, what it is. If you just click on the variables, whatever you return, it's all already shown there as a and b sum and diff, and the values of 10 and 7. So these are all the variable analysis of the ones that are given, and this one shows you in binary, in hex format and different formats. So the other one next to is expression. So if you want to read the value of the variables, for instance, if you want to read the value of a, you go to expression, add new expression, you need to get the address of that expression. So ampersand a, and then hit enter, you get this address. So click on this address and copy this address, Control C or Control V. And now I'm going to show you how to view memory browser. Windows, show view, go to memory browser, and the memory browser added to your console window. So you copied the address of variable a, you come here, paste it and hit enter, and there it is. So the value of a is 10, as you know in hex it's a, and that's the address of the variable a, and that's the value. So that's how you see it. So if you want to see the next expression, for example, say if you want to know the location of sum, value of sum, so hit enter, it will give you the address. So copy that address, come to your memory browser, you paste that and hit enter. That will automatically give you the location. FFEC got 17, so 11 and 7. So it's showing us 11 and 7. Yeah. So likewise, it will show all the results, whatever you want to see. You can check from the expression and you can see the values of it. So this is how you have to see the memory browser, and you can actually see the value of your variables and its address by doing this expression check. And if you want to check your assembly language, and you can do this by clicking on disassembly, and disassembly will give you instruction stepping mode. That means you can debug in assembly mode step by step by using this instruction cycle. Okay, so now I'm going to show you how to set breakpoints in your code. So you written a long piece of code, now you're going to set breakpoints. So I open the breakpoints. All you have to do is you can keep up to 7 breakpoints in your code. So go to that line wherever you want, double click on that line, and this a small tick mark appears, so the execution will start from there. And the second and the third, fourth, fifth, and sixth. I'll stop at that. So now when I go to run step-by-step mode, whatever these set points that you triggered, so these are all breakpoints, it's added here. It shows where and which you created, so line 22, line 25, 32, 39, 47, and 54. So I'm going and running my program now. So what this actually does is it runs the program and then comes and stop at the first execution point. That's the first breakpoint. So then you start again, and then you can see this is the call stack window. So whatever breakpoints you set, accordingly under the thread you will see those changes adding up to the pane. So I keep clicking step into, it's checking and it's going to main, and I'm going to step over, which is the next one. I'm skipping that. See, as soon as you click on step over, you get the add-on section. So this is the call stack where it, whatever call you make in the function, it keeps stacking up in hierarchical form. So that's why it's called as a call stack. So you click step over and the next step is added. So if you want to completely come out of this function loop, all you have to do is click step return. So that comes out of that code of that function and comes out to the next breakpoint. So the breakpoints in the code you use to set, it stops the execution, line by line execution, and it stops at that point, and it makes you to take a moment to think for you to do what you want to do next. So that's basically it. It stops the program and you can start to do your modifications on the code. So this is about, so far we have created from the project 1 that we learned about creating a project. You learned about setting up debug options and how you enable SWV to see your output, and also you learned about switching from C, C++ to debug perspective. On the second example, you learned about including more operational functions in there and visualizing breakpoints, how you set breakpoints, how you keep breakpoints, and you learned about call stack, and then you learned about variables and how you check the expressions by %a, %of, and also you learned about the memory browser, how or where the value of the memory browser is. So in the next example, I'm going to show you what is a watch point and how you want to set the watch point. So I give you a few minutes break, so please go and enjoy the break, and when you come back I'll show you the watch points, and there is not much to go for day 5, so I'll be quick as I can. Thank you.